Now, the instrument which is used to record the orientation jaw relation is the phase bow. The phase bow is a caliper-like device that is used to record the relationship of jaws to the opening and axis of jaws and to orient the cast in the same relationship to the opening axis of the articulator. The parts of the phase bow are U-shaped frame, condylar rods, earpieces, bite fork, locking devices, orbital pointer. This is the parts of the phase bow, bite fork, and this is the caliper-like device. This is a bow and thumb screw, anterior patient reference, and thumb screws for the earpiece. And these are the nerve nuts to lock the device. This is the assembly, transfer clamp assembly. This is the anterior elevator, and it comes with it has a different accessories which are called as Allen wrench, announced cast support, and mounting plate. Now, classification of the phase bow. The phase bow are mainly of two types. That one is arbitrary type, and second one is of kinematic type of phase bow. In arbitrary, we have fascia type and earpiece type. The arbitrary type of phase bow, in this type, the axis is located by using anatomical landmarks. Condyle rods of the phase bow are placed over the arbitrarily marked centers of hinge axes. Arbitrary phase bow are most commonly used for complete denture fabrication. Fascia type of phase bow, the approximate points on the skin over the TMJ region are used as posterior points of reference, and the condyle rods of the phase bow are placed over it. Earpiece type of phase bow, the earpieces of the phase bow are placed into the external auditory matters. Now, the kinematic phase bow, it is used to determine and locate the exact or true hinge axis point. Now, what is the posterior point of reference? Posterior reference point which locate the transverse hinge axis or the hinge axis. These are the two condyles. The position of the terminal hinge axis on either side of the phase bow is generally taken as posterior reference points. Geissi point, located 13 mm in front of the upper part of the external auditory matrix on line passing to the outer canthus of the eye. 1 centimeter in front of the line from the apex of the tragus of the ear of the outer canthus of the eye. Bergstrom point, it is 10 mm anterior to the center of the spherical insert of the external auditory matrix and 7 mm below the Frankfurt horizontal plane. Barion's point, it is 13 mm anterior to the posterior margin of the tragus of the ear on a line from the center of the tragus extending to the corner of the eye. In diagram, it can be appreciated that the external auditory matrix and the various points which are used to as a reference points for the posterior reference are depicted as A and B. Anterior points of references. The selection of anterior point of reference determines which plane in the prosthesis will become the plane of the reference. The objective of the natural appearance in the form and the position of the teeth is achieved by mounting the maxillary cast related to the Frankfurt horizontal plane. These are orbital, nasion, and ala of the nose. Frankfurt horizontal plane passes through the porion and the orbital. Because the porion is a skull landmark, Sitcher recommends using the midpoint of the upper border of the external auditory matrix as the posterior cranial landmark on a patient. This landmark on an average lies 7 mm superior to the horizontal axis. 7 mm above the orbital indicator of the articulator. The anterior point of reference marked 7 mm below orbital on the patient or position the orbital pointer. Hence, Frankfurt horizontal plane becomes the horizontal plane of reference. Now, the Frankfurt horizontal plane, it can be easily depicted in the diagram, the Frankfurt horizontal plane and the external auditory matrix. The hinge axis recording is required to check the accuracy of the two centric records. It helps in proper positioning of the casters in relation to the intercondylar shaft. Vertical dimension of the occlusion can be altered on the articulator.